on 2.4, parallel perpendicular lines. Remember to have your note sheet out to follow along. Our essential question is, how can the equations of lines help you identify whether the lines are parallel, perpendicular, or neither? After this video, you will be able to write equations of parallel lines and perpendicular lines. Parallel lines. They are lines that travel the same direction. They never touch. They have the same slope. You'll see these little arrows. That's the symbol for parallel lines. Remember to pause as you need to. Perpendicular lines intersect at 90 degrees. You'll typically see a little red box. That's the symbol for a 90-degree angle. Slopes are opposite reciprocals. Opposite means opposite sign. If one line is positive, the other slope should be negative, and vice versa. Reciprocal just means you're going to flip the fraction. For example, if we had a slope of 2 over 3, the perpendicular slope, we would have to change the sign to a negative and flip that 2 over 3 fraction to 3 over 2. Identify the slope that is parallel and perpendicular to each slope listed. So if we had a slope of 2 over 5, the parallel slope would be the same slope, whereas the perpendicular slope, we need to change the sign and flip the fraction. So parallel to 2 over 5 would be 2 over 5, same slope. Perpendicular, we need to change it to a negative and flip that fraction, so it would be negative 5 over 2. If we had a slope of negative 8, parallel would be the same, negative 8. Perpendicular, we might need to just think, okay, if it's a whole number, if we write it as a fraction, it would be over 1. So if we change the sign, it'd become a positive. Flip the fraction, our perpendicular slope would be 1 over 8. If we had a slope of 1 over 6, parallel would be the same, 1 over 6. Perpendicular, negative 6 over 1. We change it to a negative, flip that fraction. Slope of negative 4 over 3, parallel would be the same, negative 4 over 3. Perpendicular, we got to change the sign to a positive, flip that fraction, so it would become 3 over 4. Write the equation of the line in slope-intercept form that passes through the point 8, 9, and is parallel to the graph of y equals 3 over 4x minus 2. When we think of this equation, identifying the slope is important. Parallel, we're going to have the same slope. So if it has to be parallel, we know we're going to have to use the slope of 3 over 4. If we has to go through this point 8, 9, well, now we have slope. We have a point. We can use our point slope formula. We plug in our values. 9 is our y value. 8 is our x value. 3 over 4 is our slope. So this becomes y minus 9 equals 3 over 4 times x minus 8. And if we need to write it in slope-intercept form, we can distribute to get rid of parentheses. Three over 4x minus 6. And we can get rid of that 9 by adding 9 to both sides. And we get y equals 3 over 4x plus 3. So our equation would be y equals 3 over 4x plus 3. Write the equation of the line in slope-intercept form that passes through the point 1, 7 and is perpendicular to the graph of y equals negative 1/4 x plus 11. We need to look at perpendicular slope and identify that, okay, negative 1 over 4, what would be the perpendicular slope? We have to change the sign to a positive, flip the fraction, so it would be m equals 4. The point that it needs to pass through is 1, 7. So we can use our point slope form. Plug in our slope of 4, our x value is 1, our y value is 7. We plug in those values. Y minus 7 equals 4 times x minus 1. To get it in slope-intercept form, we need to get rid of parentheses by distributing. So we get y minus 7 equals 4x minus 4. Add the 7 to both sides. We get y equals 4x plus 3. Use the graphs to determine if the lines are perpendicular. To do so, we just need to count the slope of the red line, count the slope of the blue line, and figure out if it's perpendicular. So if we count our points on our red line, we go down 4 and over 3. So the slope of our red line is negative 4 over 3. Next, we can use the 2 points that are on the blue line. We go up 3 and over 4. We have a slope of 3 over 4. If you notice, that is the opposite reciprocal. The fraction has been flipped from 4 over 3 to 3 over 4. One is negative, the other is positive. These two lines in this case are perpendicular. Let's look at the case on the right. Counting the red slope, we go down 5 and over 4 for a slope of negative 5 over 4. The blue line, we go up 4 and over 3. 4 over 3, they're not opposite reciprocals. They will not be perpendicular. Are the lines of the equations parallel, perpendicular, or neither? Well, to figure this out, we need to know the slope. So the slope of this equation is negative 3 over 4. How do we figure out the slope of this equation? Well, we should solve it and put it in slope-intercept form. So we're going to solve for y. So let's subtract 4x to get the x's over. We have 3y equals negative 4x plus 6. Divide by 3. Everything needs to be divided by 3. And we get the equation y equals negative 4 over 3x plus 2. They look like they have some sort of relation, but do you notice how they're both negative? So we have negative 4 over 3 slope versus negative 3 over 4. Yes, they flipped, but the sign didn't change. So it is neither. They're not parallel because they're not the same slope. And they're not perpendicular because they're not the opposite reciprocals. Remember, for it to be perpendicular, we need one negative and one positive.